In the last video, we had said on this particular problem, we had a z-score of 2, and that we'd be able to figure out our percent of our data over here and our percent of data over here. Well, how do we go about doing that? Well, there's this big messy table called Table A, which is standard normal probabilities. Well, it allows you to be able to go ahead and find your z-scores. Now, you calculate, not your z-scores. Oh man, I messed up. Allows you to find that percentage of data that's above or below your mean once you know your z-score. So, you figure out the z-score and then you can look it up in the table. Now, your table, when you're looking at z-scores, you always want to go to 2 decimal points afterwards for your z-score. Suppose you had a z-score of a negative 2.40. Well, you go to negative 2.4 on the left side. The second number after the decimal point tells you which column to go to across the top here. Second number is a 0, so we got to go to here where it's 0. We come down this column over on this row. Wow! We get this number of 0.0028. So if we had a z-score of negative 2.40, the proportion of data that would be below that or less than that would be this. Not much. If you had a z-score of a negative 2.41, well, you still got to go to that negative 2.4. But since the second number after the decimal point is a 1, you got to go to where the column at the top says the second number after the decimal point is a 1. You come down that column, crossing that row, and you get 0.0080. That's the proportion of data that's less than whatever value we would have had that gave us this z-score. Your table A always tells you what's less than or what's below. So even if you had a z-score of negative 2.46, you go to that negative 2.4, second number after the decimal point is 6, so you got to go to the 06 column, come down that column, you get this right here. That's using table A. That's what we're going to have to use as we go through these problems. Once again, just for clarification, by the way, if it's in big bold print, boxed in a big red box, well, you must know it's important. Says table A tells you the data that's less than. It always tells you what's less than or what's below. Remember that! So, which one of these two scores is better? We have a math test. The mean of the math test is 70. The standard deviation is 8. We have an English test. The mean is 74. Standard deviation is 16. Which of these scores would be better if they had a 78? If you got a 78 on the math test or a 78 on the English test, which one would be better? Well, all we have to do is figure out the z-scores and we can compare. Z-scores basically allow you to compare apples to oranges. So we got to take our mean for our English, which is 74, our standard deviation of our English, our 78 score. We subtract on top, we get 4. 4 over 16 is a quarter, so we get that. For our math, we take our 78 minus our mean of 70 over our standard deviation of 8. We subtract, we divide, we get 8 over 8, we get 1. So the math gives us a z-score of 1. So this is our math right here. Now, our English gave us a z-score of about a quarter, which would be about right here. Well, which one has more area to the left? Well, obviously the red one, since it's farther to the right, there's more area over here. So that means the math test, 78, is better, since it's a higher z-score. Now, what do you do when your z-score is not a nice normal number like 2 or 3? Well, that's once again where we figure out the z-score and have to use that table A thing. So here we have our action figures. We have our mean, we have our standard deviation. We want to know what percent of our action figures whose height is less than. So we take our data value, which is our x, plug in our mean, which is 17 over our standard deviation of 2. We go ahead and subtract, divide. Wow, we get this. Then we have to go to table A. We need to go ahead and find on the left-hand side, the first two numbers here tell us what to do on the left-hand side, negative 1.4. So we got to go down to negative 1.4 on the left-hand side. Oh, here's negative 1.4. Which column do we have to go over to? Well, the second number after our decimal point is 5, so we got to go to the old 5 column. Come down that column over on that road. Oh, there we go. This table, remember, always tells us what's less than. Hey, we wanted what was less than. So, if our table tells us what's less than and we're looking for what's less than, that must be our answer. The only thing we have to do to this number is change it into a percent. So we're going to move our decimal point over, boop, boop, 2 spots, and we get 7.35. That's what we're looking for. By the way, we put this right here, and that tells us, once again, our area that's in this little kind of irregular triangle shape right here. And that's what we were looking for. Table A always tells you what's left of that z-score that we figured out. Oh, here's another similar type problem. Oh, more than! Uh-oh, what do we do? Well, we can still figure out the z-score. Our table tells us what's less, but we're looking at for what's more than. So we got to figure out a couple of things. So let's just do that z-score thing again. So we'll take our data value of 12 minus our mean of 17 over 2. We need to go ahead and subtract, divide. Boop, there we go. We always want to have 2 decimal points here because that's what our table is set up for. So there wouldn't be a 0. So we added that 0 there just to make sure. Then we got to go to negative 2.5 in the left-hand column. Go to negative 2.5. Oh, there we go. Second number is a 0, so you got to go down the O0 column. There we go. That's what we get. So a z-score of negative 2.5 is right here. Our table just told us this red area. The red area is less than, but we're looking for more than. We're looking for the white area. Well, what do we do about that? Well, remember, in one of the first slides in the last video, we said that our total area is always 1. If the total area is 1, and we know the red area is 0.0062, all we have to do is just go ahead and do a little bit of subtraction to be able to get the white area. So we take our 1 minus our 0.0062 that we got out of the table, because that always tells us what's less than, which is the red area, and we're looking for the white area, so we do that subtraction from 1. Oh, we get that. But remember, it says percent. So we got to move our decimal point over 2 spots. 99.38%. Relatively easy. So what do we do when we're looking at this situation? We have our mean, standard deviation. What percent of the bottles or proportion of the bottles are between here and here? Oh, well, we're going to have to figure out the z-score for each one. So the z-score for the 12.2. Well, here's our z-score formula. We take our data value of the 12.2. Oh. Uh-oh. We got a typo here. Ah, it's just magically fixed. Cool. We take our data value of 12.2 minus our mean over our standard deviation. We do our subtraction. Well, then we got to look up a positive 1.00. So we go down to 1.0 over to the O0 column. We get a 0.8413. So we'll write that down. Now we'll go ahead and we'll do our 12. So we'll figure out 12 minus our mean over our standard deviation. And we get a negative 1. Then we got to find a negative 1.00. So we got to go down to negative 1.00 in the O0 column. We get this right here. So we're going to take that, write it down. Okay, so we got to figure out what's between. So we just figured out this white area right here. Oh, come on, I need you in front here. Just a second. Okay, this is the white area. Now, this right here, that tells us everything that is in the green. Well, just a second here. So this number right here tells us everything that's in the green and in the white. So that 0.8431 tells us all this. Now, what we have right here in the blue, dark blue, that's only this. We want only what's left in the green. Well, if we know the whole thing right here is the 0.8413, and we know this is here, and we want only the dark green here, all we have to do is just subtract those two numbers we got from the middle of the table. So we take those, subtract, we get this. Now, in this particular case, we're not changing it to a percent because it doesn't say percent, it says proportion, so we're going to leave that. Well, that's your basic z-score stuff. With that in mind, you should be able to handle the problems that you're going to have to work on for class. Thanks for tuning in to Math Man Radio.